Hello and welcome to Rationalizing the Denominator. Here's the thing. When you have a fraction, you can't have a square root in the denominator. It's not in simplest form. So in order to make it in simplest form, we need to make sure that all the radicals are out of the denominator. It's okay to have it in the numerator, but we can't have it in the bottom. So here's what we do. Something like this, there's a radical in the bottom. That's a problem. So what I'm going to do is I'm going to multiply this fraction by something that's equal to 1. I'm going to multiply it by square root of 2 over square root of 2. Because I know this is equal to 1, so it's not changing the value. I'm just saying, hey, times 1. That's going to keep it the same. But what it does is it just changes the way that it looks. So when I multiply by this, square root of 2 times square root of 2, that's a pair of square roots, right? We know that's equal to plain old regular 2. And then 1 times radical 2 is radical 2. Now this is okay. No square roots down here. All the square roots are up here. That's fine. This can be in simplest form. This is acceptable. This is okay. So if we have something like this, I look to say, what can I multiply by that would get the bottom to be a plain number and not a radical? Well, if I know if I multiplied this by radical 3, that would do the trick. So let's multiply it by radical 3 over radical 3, since that's really just the same as 1, and it doesn't change the values at all. So that makes this plain 3, great, and that makes this 2 square roots of 3. No radicals, I'm good. Something like this, we'll do the same thing. Square root of 3 over square root of 3, just like we did. And this is 3, and this is square root of 18. Now, up here, we can't make this any smaller. We can't make that any smaller. But we could make square root of 18 smaller. We've learned how to simplify that. So we can make this 9 and 2, and 3 and 3. And we know that these pairs of square roots makes that a plain 3 with a radical 2 left over. So this is equal to plain 3 with a radical 2 left over. And now you might see something that could cancel. See how the plain 3 can cancel with the plain 3? The answer to this whole thing is just square root of 2. This work was kind of in the way. So all of this, and if you see, this is why square root of 6 divided by square root of 3, we could divide those and get square root of 2. That's also legitimate. This is all fine. Okay, something like this. If I divided these, it would still leave me a radical in the bottom. So it wouldn't necessarily help me. Let's multiply by square root of 10 over square root of 10, because I know that'll make a plain 10 in the bottom, which is what I want. Then here, this will be 2 times the square root of 5 times 10 can be multiplied together to be 50. Let's see if we can simplify the square root of 50. Let's go 10 and 5, and 2 and 5. Here's a pair of 5s. So 5 with a leftover square root of 2. So really what I have here is 2 times a 5 square roots of 2. I can multiply those plain numbers together. This is this, right? I can multiply that and get 10 square roots of 2 over 10. And now you might see the thing that could cancel. The plain 10s can cancel, and I'm left with square root of 2. So things to take away. We can't have radicals in the bottom, so we multiply it by something equal to 1. Equal to 1, equal to 1. Then that gets rid of the radical in the bottom, and then I see, can I simplify this square root that's in the top and make it even smaller, because maybe some plain numbers will cancel. They cancel here and they cancel here, and that'll happen oftentimes.